It is day 20 of 50 days of tutelage. In today's class, we'll be talking about momentum and impulse. If you flash back a little bit, you realize that we had discussed about motion, all sort of ways that motion can occur. And also we discussed about Newton's law of motion. See, the ideas of all these things that you have learned before is going to be very, very useful in learning about momentum and impulse. So to make it very simple for you to grab, what is the concept of impulse? Basically, if you have an object, let's say this is the object, of course, this object will have mass. So it has a mass m. Now, the moment you set this object in motion and it's moving in a certain direction, so let's say it's moving with a velocity v. So at this point, it possesses impulse, it possesses momentum rather. So because momentum is actually the combination of the mass of a body and the speed with which they are moving. So to put into perspective is the fact that if somebody should grab a bullet, so let's say this is a bullet, if somebody should grab a bullet and the same bullet is loaded into a gun, I'm just going to draw, yeah, if the same bullet is loaded into a gun, the bullet that is loaded into a gun will do more damage than a bullet that human will throw at you. What is the difference between the two? They both have the same mass, but what they have differently is the velocity. Now, the same way as well, if two objects are moving really fast and they are moving at the same velocity, but one of them has a bigger mass than the other, then the one that will do more damage is going to be the one with the bigger mass. So the combination of mass and velocity together is what gives momentum. And therefore, you can make the momentum to be higher by having a higher mass, or you can make it higher by having a higher speed or velocity in this case, or you can even make both of them to be very, very high. So this concept is actually very, very important such that small objects, little objects can actually cause great impact. It is due to the fact that they have what? Momentum. Due to the fact that they have momentum. So momentum is the quantity of motion that a body possesses. It is the quantity of motion that a body possesses. So that is the rate at which it is moving. How fast is it moving? How fast is it changing distance rather, or how far is it changing displacement per given time? So that's basically what momentum is. So, and you would be familiar with the fact that momentum is the product of mass and velocity. Take note, momentum is a vector quantity. Momentum is a vector quantity. So it has both magnitude and direction. So therefore, if it has more value, it has more impact. If it is also moving in the specific direction, it also has more impact. So momentum is affected by direction. So take note of that. And then the Newton's second law of motion actually talks about the fact that the rate of change of momentum is proportional to, so the rate of change of momentum, so change in momentum is actually the same thing as force times time. And this force times time is what we know as impulse. Impulse. Now, why is it different from momentum? Even though momentum and impulse, they are dimensionally the same. They are dimensionally the same, but there's a difference between them. So what is impulse? And what is it equal to exactly? So momentum is the product of mass and velocity. However, impulse is change in momentum. Impulse is change in momentum, and the change is not actually observed over a long period of time. The change is observed over a short period of time. So I'm going to give you an example now. So let's say there's a wall here, and then you kick a ball. So let this be a ball. I'm just going to make that like the World Cup ball. Well, if it doesn't look like it, I guess it's in the mind. It's in the mind. So just think about it in the mind. I think it looks like the World Cup ball already. Yeah. So you kick this ball, you kick it towards, so let's say Ronaldo is kicking the ball, and you kick the ball towards the wall. Oh, the ball seemed too big than the wall already. So I'll just reduce that. So you kick the ball towards the wall. So as the ball is going, it's moving, it's moving, it's moving. Then it hits the wall. The moment it hit the wall, in a split second, it bounces back. That sudden change in momentum that this body experiences is what is regarded to as impulse. So impulse is actually change in momentum all of a sudden change in momentum. That is what impulse is. But dimensionally, they are the same thing. And this is what the Newton's law, second law says. So where you have change in momentum is what equals ft. So if change in momentum itself is mass times velocity. So when you say change in momentum, that will be final momentum. So that will be p final minus p initial equals ft. And so when you do that, final momentum will be mv minus initial momentum will be mu, and this will be equal to ft. So if you divide both sides by time here, so you have this. By the way, take note, I've told you that when you're dealing with force in physics, it is always the net force. It is always the net force. So m is common here, so this can be mv minus u divided by t, and that will be equal to F net. And what is v minus u over t? You remember, a equals v minus u over t. So you have ma equals F net. So this is the Newton's second law of motion, which actually relates force with change in momentum. So let's continue quickly. So I've been able to introduce you to the concept of impulse and the concept of momentum like that. Now let's now do some basic things, some basic analysis about momentum. So the first thing I want to talk about is that we can actually have more than one body in a system. And then this system, these bodies, they are colliding together with each other. So let's say you have body one. You have body one. So let's call this one M1. This is M1. And let's say you have body two. Let's call this guy M2. So if these guys were to collide together, a lot of things can happen. So therefore, we analyze them based on collision. And the collision, we have two types of collision. We have what we call the elastic collision, and we have what we call the inelastic collision. What does it mean for a collision to be elastic? When a collision is elastic, it means that whenever the meeting happens, whenever the collision happens, the two bodies or the bodies that are colliding together, they move separately apart again. They do not join together to what? To move. They do not join together to continue moving afterwards. So elastic collision is such collision such that when there is what? When there is a collision, there is also a separation after collision. But when it is inelastic collision, it's actually what happened there is that when the body collides, they tend to kind of stick together afterwards. They stick together afterwards. That is inelastic collision. But that's just a loose definition. There are some things that we need to take note about elastic collision. Although we don't actually have, in the ideal world, there is no perfectly elastic collision. Reason is because in terms of perfectly elastic collision, there are conditions that are satisfied actually. First of all, one of the things that will be done there is that the momentum will be conserved. If you have a perfectly elastic collision, the momentum will be conserved. Another thing here is that energy is going to be conserved. And as you can see, because they are moving, they possess kinetic energy. So energy is going to be conserved. In this case, I'm talking about kinetic energy for perfectly elastic collision. Now, in the case of inelastic collision, momentum is still conserved. But in the case of energy, their kinetic energy is not conserved. Their kinetic energy is not conserved in the case of inelastic collision. But here's the case. When it comes to energy, actually, everything that happens actually requires energy for it to happen. So if these two bodies, if they should collide together, one of the things that we can get from them is sound. And also, due to friction, it will be generated. You see, there are so many other things, but these two things alone that I've listed, heat and sound, they require energy to be produced. And where will they get the energy from? The energy that these two bodies that they possessed initially before collision. So that implies that even if they were to separate themselves apart, their energy would have reduced. Reason is because they have used some of the energy to deal with heat and to deal with sound, and maybe other things as well that might exist. So in practice, what we do is that we ignore such energy that can be lost due to heat and sound, and we just focus on the energy that they use for their motion only, and they use for collision. So I think you get the idea now. Elastic collision, momentum is conserved, energy is also conserved. Inelastic collision, only momentum is conserved, energy is not conserved. And so here's the technical part. You need to do proper analysis when you are doing sum of momentum, because momentum is vector quantity while energy is scalar. In the case of doing momentum, so if I say momentum is conserved, what I'm trying to say is that total initial momentum equals total final momentum. And how do you now calculate total initial momentum? Because this is where the problem always lies. Now, what you need to do is that if you have body A, so let's say this is body A, and then you have body B. These two bodies, they can collide with each other, and there are different cases that they can move. The first case is, let's say body A is moving to the right, body B is moving to the left. The second case is when body A, so let's address the first case. So what you notice here is that you need to pick a side. You need to pick a side for your positive, and you need to pick a side for your negative. It is always advisable to always pick the bigger side for your positive. But also, because this one appears to be bigger, does not mean that it will have the higher, higher momentum. Because if this is smaller and it has a very higher speed, a very high speed rather, it is going to have more momentum than this big guy. For instance, if the mass of this is 2 kg and the mass of this is 5 kg, but if this one is moving with a speed of, let's say, 10 meters per second, and this one is moving with a speed of 1 meters per second, the momentum of this one is 5 kilogram meters per second, or Newton second, any of those two, and the momentum of this one is going to be 20 kilogram meters per second. So you can see the difference now. This one has higher momentum, even though it is the one with the smaller mass. So take note of that. So, but it does not really matter. As long as you are consistent, you are going to always end up getting a perfect result. So choose a side as positive. Most of the time, we choose right. Anything moving to the right, we choose it to be the positive one. And anything moving to the left, we choose it to be the negative one. So in this case now, if you choose this as positive, this will be negative. So therefore, total initial momentum will be, so what's the momentum of this small guy, A moving to the right? That will be 20 plus, now, because this guy is moving to the left, the momentum is 5. So you have what? 20 plus minus 5. And therefore, what you have at the end of the day is 15 kilogram meters per second. So that is when they are moving in opposite direction to each other and they still collided. Now, another one is, let's say both of them are moving in the same direction. So in fact, what I just described now is perfect, because since this guy is moving with a very high speed, higher speed than the second one, it will catch up with this and they will collide together. So if they move in the same direction, so that's right and right. So in that case, you are going to have 20 plus 5, which will be 25 kilogram meters per second. So I've given two cases now. When they're moving directly opposite each other. Number two, when they're moving in the same direction. Another one is that when one of them is at rest. If one of them is at rest and the other one is moving, whether in this direction or whatever, so the total momentum will be the momentum of the one that is moving. So the total momentum in that system will be the momentum of whoever it is that is moving and is not at rest in that situation. So what matters is that you need to always consider this when you're finding total initial momentum. To find total initial momentum, direction is very, very important. You don't just say because it is total, then you begin to add everything. You have to consider the direction of this whole momentum thing before you start adding them up. So everything moving in the same direction, they will have the same sign. So if you have selected a positive sign for anything moving to the right, so all of them will have a positive sign. But anything moving to the left, they'll have a negative sign. Of course, there is actually like much more complicated case to this, whereby you begin to deal with it in terms of y and x components. But I'm not going to cover that in this particular video. So maybe in some our later classes, we're going to be talking about that. So now, the last thing I want to talk about here is that for the case of sticking together after collision has happened, this is total initial momentum. Now, what about final momentum? So one thing you would ask is that you don't even know how this bodies, how they will move after collision. You don't need to worry yourself about that. Use whatever information that you are given and you are limited to, just work with it that way. Whatever the case is going to happen. So for instance now, you don't know what is happening to this A after the collision. You don't know what is happening to B after the collision. Although questions would actually signify what is happening to at least one of them. So but all you have to do is to just say total final momentum is M final, MA final times VA final plus MB final times VB final. See, the way it works is that if you had done your total initial momentum very well, when you begin to solve for any of this guy based on what the question is about, you probably will get a positive result or a negative result. If you get a positive result, that means that that body is moving to the right. Don't forget, you had already selected that right is positive earlier. And if you get a negative result, it means that the body is moving to the left. So you wouldn't be making any error. Once you get your total initial momentum correctly, then you are good to go. You can always do all of those things. Another special case is the case whereby they stick together. So in the case where they stick together, we say they have what we call a common velocity. So in that case, your total final momentum is going to be MA plus MB. Everything will be multiplied by that common velocity that they have. But the moment they stick together, that means that the collision is not elastic, it is inelastic, and therefore you will not have kinetic energy to be conserved. But in the other case, kinetic energy is also conserved, which means that total initial kinetic energy is the same thing as total final kinetic energy. And for that elastic case now, so you can have something like this: half MA initial VA initial squared plus half MB initial. I think it's just MB, so there's no need for initial. It's the speed that has initial. VB initial squared will be equal to half MA VA final squared plus half MB VB final squared. So you can see in this case, I don't have to worry about subtraction and addition because this is energy and energy is scalar quantity. So when you are talking about their total, you just add everything in magnitude like that. And this one half is common, so you can just get that out. So you have at the end of the day, MA VA initial squared plus, where in this case now, V is going to be the speed, no longer the velocity. So that will be MB VBI squared equals MA VAF squared plus MB VBF squared. So what this implies is that this is only going to be true for elastic collision. But when it comes to the case of inelastic, when they stick together after collision, what happens is that the energy will reduce. Kinetic energy will fall down, will plummet. So that is another thing that you need to pay attention to. The last thing, I was talking about hitting a ball on the wall earlier. So where is my ball? Okay, yeah. So if this body was moving in this direction in the first place, that is to the left. Now you can take your initial direction as being positive, and then because it's moving to the left, you can also take it as being negative. It does not really matter. Whatever you do, you always end up getting the same result. So you want to get what we call a change in momentum. So change in momentum, know that it is final momentum minus initial momentum. Now, to get your change in momentum, the first thing you need to analyze is that find each of the momentums separately. So if right is your positive, that means that the initial momentum is this and it's going to be negative. So therefore, if let's say that will be mu, then that implies that your initial momentum is going to be negative mu. Negative mu. Why? Because you have decided that left is what? Negative. Then your final momentum, when this ball bounces back and is going now again, is going to have mv. So therefore, in this case, you have positive mv. So slot that into this expression. Change in momentum equals final momentum is what? mv minus what is initial momentum? Negative mu. Negative mu. And that will be equal to mv plus what? Mu. So I believe you understand that now. So oftentimes when you want to look for impulse, you need to find change in momentum. And this thing I just explained now is very important that you take note of it. Direction matters when you are dealing with momentum, and when you're dealing with impulse, direction matters. Now, you could have decided that, okay, your initial direction is going to be, so what this means is that the change in momentum, everything happens towards the right. That is why everything is positive. But you could have decided that your initial momentum direction is what you want to make positive. So that means that Pi is going to be positive Mu. But the opposite direction is where the final took place. So therefore, you have negative MV. So if you slot that into this expression, so what you're going to get is, let me just put that right here. You're going to get, so what is P final? P final is negative MV minus, what is P initial? Mu. So you see that negative sign is common here, so you have negative mv plus what? Mu. They are still the same thing. The only difference is the direction. This one, negative sign is for the right, for this particular orientation. So therefore, it's showing that it is moving to the right. And then this one too, positive sign is for the right. It's showing that it is moving to the right. So please take note whenever you're doing anything that has to do with change in momentum. And that's it on momentum and impulse. Don't forget to like, comment, engage the video, and subscribe if you have not done that yet. We continue the class tomorrow. Make sure you are taking notes. I'll see you around.